Hi everyone, this is the video lesson for 5.2 special right triangles. This is one of my favorite topics in geometry and later in trig. I think it's fun finding the sides of triangles. So our first formula is for the 45, 45, 90 triangle. So we have two angles that are 45 and then the third is a 90. It's all based on right triangles. So our two angles are 45 and then our other one is a 90. So if we have two angles that are congruent, what does that tell us about sides? Very good. That means that we'll have two sides congruent as well. We learned that that was the converse of the isosceles triangle theorem back in chapter 2. So that means that these two sides are going to be congruent, the two sides across from those angles. So we're trying to make formulas for the sides to be able to find the side lengths, because what's going to happen is they'll give us one. It doesn't matter which one they'll give us, and we have to figure out how big the other ones are. So our formulas from the theorem says that we have those two sides will be x, because we know they're the same, and that to find the third side, it's this value times the square root of 2. So it would be x root 2. And we're going to do something in class that explains more how we find those formulas, but for now, you can just know that that's what the formulas are. So for our 30, 60, 90 triangle, we have two angles, 30 and 60, and then it's going to be a right triangle. So the 30 goes here because this is our littlest side, so the littlest angle. It's going to be across from the littlest side. So that means that this angle would be 60. So for the 30, 60, 90, we're going to do the same thing and set up like formulas for our side lengths. So for the 30, 60, 90, across from 30 is always x. Across from 60 is x root 3, and across from 90 is 2x. So one way that you can remember these formulas is that across from the littlest side, or littlest angle, is the littlest side. So x root 3, and 2x. The square root of 3 is smaller than 2, so it's 1.73. So that's how we know, like, this is 1, this is 1.7, and this is 2. So littlest side goes with littlest angle, and they go up. The same thing works here. We have 45, 45, and 90. So the 45s are going to be the same, and then the 90 is the square root of 2. And the square root of 2 is bigger than the one that we have on the other side. It's 1.4. So we know the little side goes to the little angle, the bigger side goes with the bigger angle. So when we try to solve for the missing sides, sometimes they'll put variables there, sometimes they won't. Sometimes they'll try to mess us up and put x's in places that x maybe doesn't belong. Sometimes they put x in the spot that we put it for our formulas. So at first you kind of have to ignore the variables that are on your triangle, write in your formulas on top of your triangles, and then go from there, okay? And then just look back at the letters that they wrote that are in the problem at the very end. So when you look at the triangles, you have to determine, is it a 45, 45, 90, or is it a 30, 60, 90? So for this one, they tell us we have two congruent angles. So what does that mean about these two sides? That they're going to be congruent. So if those angles are congruent, they have to be 45. So this is a 45, 45, 90. And we know that the sides across from the 45s are x, and the side across from the 90 is x root 2. So the first step is always to write your formulas on your triangle. So the next thing would be to look for what they gave you. So they gave us this side. So that's one side that we already have and we don't have to find it. So once you figure out which side you have, you set it equal to the formula that you wrote on there. So if you're lucky, it's x, and then you don't really have to do much else. But for this one, it's not just x, it's not on this side. So that means we set our formula equal to the side we were given. So x root 2 is equal to 5 root 2. So what we need to do from here is solve for x, because once we know x, we can plug it in on the other formulas. So to get x by itself, we have to get rid of the square root of 2, and these are being multiplied. So how would you get rid of something that's being multiplied? Very good, we divide. So divide by the square root of 2. So the square root of 2 divided by the square root of 2 is 1. So we get x equals, and on this side, same thing, those are going to cancel out. So x is just 5. So once we're done, we take our 5 and plug it back into wherever we had an x. So 5 would go here, and 5 would go here. So that means that A is equal to B, which is equal to 5. So when you write those in on your triangles, I want you to always circle them or square them or highlight them or highlight and circle something so I know that those are your side measurements. Because we write a lot of stuff on those triangles and sometimes they might not have variables, like here we had A and B. So I might not know what your answers are unless you point them out to me, okay? Okay, so next problem. So in our next problem, we see that they have an x as one of our sides. And that is our formula, but we're going to pretend that that x isn't there and not think of it as our formula. So just ignore the variables that are there for now. Remember, we didn't look at the A and the B until we were at the very end. So for here, we know across from 45 is going to be x. So the other across from 45 is another x. And across from 90 is x root 2. So after you write your formulas in, the next step is to find the side that they were given to you. So the side that was given to us is this side down here, which is a 7. So we set that equal to our formula. So we can see for our formula x that it's equal to 7. So now that we know that x is 7, we plug it into the other x's that we wrote. So on this side, we plug in a 7. And then on this side, we'll plug in a 7 there. So that would end up being just 7 root 2. Okay, so if we wanted to write our answers like we did over here, this side was labeled as x. So x is 7. And the hypotenuse was labeled as y. So y is 7 root 2. And that would be it for that one. So as you can see, if you're given the side with x, it makes your life a lot easier because then you just have to plug in into the other numbers. If you're not given the side of x like we did on the first example, then you have to solve and find x. So go ahead and try the next 3 examples in that row, and when you come back, I will show you the answers. So pause your video, please. Okay, so here's all 3 problems. Well, let's look at just the first one first. So what I did is I wrote in my formulas on the sides, ignoring the letters that were there. So we were given the hypotenuse, which is x root 2. So I set that as an equation. So x root 2 equals 2 root 6. I solve for x, so I divide by root 2. And then 2 divided by 1 is 2. Root 6 divided by root 2 is root 3. If you need help with that square root stuff, check out my square root or radical video, simplifying radical video, and that should help. Okay, so now I know x, so I can plug it in to all my sides that had an x for my formula. And that would be it. So side x is 2 root 3 and side y is 2 root 3. And that's it. So next we have, this problem looked a little more complicated because they gave it to us as a square, but we had that those were congruent and we have the right angles, so that means that it would be a 45-45 because then that line is bisecting. So we have x root 2. So we were given x, so that makes our life a lot easier. So x is 9, we just plug it in there, and then we plug our 9 in here, so we get x is 9 and y is 9 root 2. In the last example, we were given the hypotenuse. So we said x root 2 is equal to 12, and then I solved for x. So if x root 2 is equal to 12, divide by root 2, so I get that. We can't have a radical in the denominator, so we have to rationalize the denominator. So we multiply by the denominator to the top and the bottom, and then we just simplify that, and we end up with 6 root 2. If you need help with that, like I said, look at the radical video. So now we know x is 6 root 2, so I can plug it into both of the sides that I labeled as x. So that would be side m and side n. So m and n is equal to 6 root 2. So we look at our bottom examples. Those are for our 30, 60, 90. So we do the same process. It's just our formulas are a little bit different. So on our 30, 60, 90, we know across from 30 is x. Across from 60 is x root 3. And across from 90 is 2x. So we were given the side across from 60. So we make it equal the formula that's on that side. So x root 3 is equal to 4 root 3. And we're going to solve for x. How do we solve for x? Good. We divide by the square root of 3. So we end up that x is equal to 4. So now that we know what our x is, we just plug it in wherever it is for our formula. So over here, x was 4, so that means that this side is going to be 4. And over here we had that side b was equal to 2 times x, so side b would be 2 times 4, which is 8. So a equals 4, and b is equal to 8. So now we have all three sides. And that's pretty much it. I think the hardest part probably will be doing all your radical operations. So let's skip over to this one. So we're going to do the same thing. Across from 30, we put our formula across from 30 is x. So if that's 30, that means that this one's going to be 60. Across from 60 is x root 3. Remember, we ignore that x, pretend it's not there. Across from 90 is 2x. So for this one, we were given our x side. So now we just have to take that and plug it into the other ones. So the side that's labeled as x, formula is x root 3. But we know that x is 7 root 3. So if we plug that in, we have 7 root 3 times root 3. So that'd be 7 root 9. Square root of 9 is 3. So we get that that side is 21. So side y is 2 times x. So that would be 2 times 7 root 3, which is 14 root 3. I probably can't see that. There's a 7 there. So now we have side y is 14 root 3, and side x was 21. So go ahead and pause your videos and try the other 3 examples, and when you come back, I will show you how to do them. Good luck. So for the second example, we lucked out on this one and we were given side x. So all we had to do was plug that into the formulas on the other side. So plug it in here and we get 8 root 3. Plug it in at the bottom. 2 times 8 is 16. So side n was 16 and m was 8 root 3. On this one, it wasn't so easy because we weren't given side x. We were given the side that's across from 60, the x root 3 side. So we set up our equation. We solve for x. So we end up with 9 over square root of 3. But we can't leave that square root in the denominator. So we multiply by the square root of 3. And we do a bunch of algebra. And we end up with 3 root 3. So that means side x is 3 root 3. And then we can take that x and plug it in to side y, and we get 6 root 3. So for our last example, they tried to confuse you on this one too and gave you a rectangle. But we have side 30 and 90, so that has to be our 60. So plug in our formulas on each of our sides. We were given the hypotenuse, the 2x side, so we can solve for x. And we get that x is equal to 8. Forgot to divide by 2, apparently. So x is equal to 8, so that means that side y is equal to 8. And then when we take that x and plug it into x root 3, we get that the x root 3 side, or the side across from 90, is 8 root 3. So that's the side that's labeled x on here. So thanks for watching. Make sure you watch that radical video if you were having problems with the radicals. Werner out.